All right, so we've been doing a few examples of relative change, and now we can look at relative error literally. So the radius of a circular disk is given as 24 centimeters with maximum error in measurement of 0.2 centimeters. So what this means with notation is it's saying our radius is 24, and when it says maximum error, again, that's our D, and in this case is R, because that is our error. Both of them are in centimeters. So what that means, picture-wise, is this. We have a circle with radius 24, and we can have a maximum circle radius of 24.2, or a minimum circle with a radius of 23.8. So that's what our error is talking about. So what are they asking us to find here? They want to first find an area function for a disk. So an area for a circle is pi r squared. And then we take the derivative. So a prime equals 2 pi r. And so this represents dA, and we took the derivative with respect to r. So our units for this are going to be centimeters squared over centimeters. So now it says find the formula for the change in area. So what we're looking for is now what is the error for the area. So we're going to break up this formula. So we have dA over dr is equal to 2 pi r. And so if we want now the error in area, we bring the 2r to the other side by cross multiplying. And now we have our formula for our change in area. Okay. So use this formula now to estimate the maximum error dA in the calculated disk. Well, we know our radius is 24 up there, and our dr is 0.2. So if we substitute those, plug them in our calculator, 2 pi times 24 times 0.2, we end up with 30.1593. And this is the change in area, so we need centimeters squared. That's what we're going to get. So we expect with an error of 0.2 centimeters for 24, we're going to get an error in our area of 30.1593 centimeters squared. Was that good or bad? I don't know. Someone's up here saying, look, it's only an error of 0.2. And so now we have to argue, well, yeah, that's good? Bad? I don't know. What's next? Relative error. Well, let's find out what that area actually is at 24. So pi times 24 squared would give us our actual area that we have with a radius of 24. So second pi times 24 squared equals 1809.5574. 1809.5574 centimeters squared. Okay, so let's review this to see what's going on. We have our area. It's pi r squared. So if our radius is 24, our area would be 1809.5574. Now that error in our radius can be 0.02 centimeters, so we could go up to 24.2 or down to 23.8. If we take the derivative, it gives us our approximate change, rate of change for our area with respect to the radius. So we get dA dr. We then found this formula. We plugged our 24 and 0.2 in to find out our change in area. So we're expecting with a 0.2 change in radius at 24, our change in area would be 30.1593. And now we're asking, is that good or bad? Well, let's find the relative error. So again, relative error is just that ratio. You always want to think to yourself, it's our actual change, right? It's dA over A. That's going to give it to us. It's our relative change over our actual area. And this is giving us our proportion, our ratio of the two to see if it's good or bad. So we take 30.159, delete that out of there. Divide it by, we'll grab that one and bring it down, hit enter, and it says 0.0167. Well, if you tell someone, hey, it's 0.0167, that's our relative error, they're going to go, okay, what do they really want to hear? They want percent, and that's why we then convert it to a percent error. And that just means to take that ratio and make it a percent. So how do you do that? You don't put a 1 in front of it. You put 100 times 0.0167, plug it in your calculator, and that just means move the decimal over. So it's 1.67% off. So now you can argue, look, you make an error of 0.2 centimeters with only a radius of 24, and our area is going to be off by 1.67%. That's not good. We need it to be like I'll take a 0.01% or a 0.1%. But there you have it. That's relative error.